And in the third unit, we have a topic known as all pairs shortest paths. Now, this algorithm of, this problem of all pairs shortest path can be solved using or is solved using dynamic programming. All pairs shortest path in this algorithm is known as Flyod-Warshall's algorithm. Now we have seen Dijkstra's algorithm to find single source shortest path. We can apply Dijkstra's algorithm on this problem n number of times to get the solution, where n is nothing but number of vertices. Now, because Dijkstra's is single source, so from one source we find all shortest path. So if this is applied on vertex 1, again Dijkstra's has to be applied on vertex 2, vertex 3 and vertex 4, and we get the solution to this problem. So Dijkstra's itself will take O of n square, compute the path, and when we try to apply this for n number of vertices, then Dijkstra's algorithm, or not Dijkstra's, the solution for this all pair shortest path would be taking up O of n cube as the time complexity. So that is not, that is one way of solving, but that will not be counted as the dynamic programming approach. Dijkstra's algorithm is actually a part of greedy approach. So we will look at a problem, we will look at how to solve this problem using Flyod-Warshall's method. Now this Flyod-Warshall's algorithm also will take O of n cube as a time complexity, same as when we apply Dijkstra's algorithms n number of times. We take the same. But Flyod-Warshall's algorithm will take the help of dynamic programming, where we make sequence of decisions, and every decision we try to choose or make will lead us to an efficient cost or efficient path. Now the concept of Dijkstra's algorithm is that, the concept of Flyod-Warshall's algorithm to find all pairs shortest path is that we need to find a path from or, or we need to look at the possibility of a path from an intermediate node and whether that path will lead us to a better cost path or not. So let us consider an example of finding a path from 1 to 3, node 1, or vertex 1 to vertex 3. There is a direct path which has 11. But do we have a path from any intermediate vertex which will be shortest? Now, from 1 to 3 direct, the cost is 11, but from 1, if you have to go to 3, then there is a path with the intermediate node as 4. So which has cost as 7, and then from 4 to 3, 1 which is 8. This is a better path than the direct path from 1 to 3. But is there any other intermediate node from where we can reach the from 1 to 3 in a much lesser cost? There is another node 2. So from 1 to 2 it takes 4 as the cost. From 2 to 3 it takes 2 as the cost. So 6. So among this we found a better path which goes through an intermediate node 2, though it also goes through a path goes through intermediate node 4 also, but it also goes to intermediate node 2, another node which is much better. So the concept here is to find the paths taking an intermediate node and finding whether it leads to a better path or not. So generally when we have to find a path, we look at a direct path and then look at the path from source to destination going along intermediate nodes. But in Flyod-Warshall's algorithm, what we will do is we will look at a path whether there is a direct path or not. If not, we will take each vertex. Whether it will lead to a path or not, that's a different issue. But we will take each vertex and consider that vertex as an intermediate vertex and then find the path. Now this leads us, or what Flyod-Warshall says is that, leads us to an equation known as ek of I comma j is equal to minimum of ak minus 1 ij, comma, minimum of these two, comma, this is a direct path, ij is the direct path, because we are trying to find a path from vertex I to vertex j. So this is a direct path. That is a minimum, we have to choose now, minimum between the direct path from I to j or a path from, obviously a of k minus 1 is there, path from I to k and k to j, plus k to j. So where k is nothing but an intermediate vertex. So this is how we try to apply the logic of finding a path, some path which is better. So what is this k? K is an intermediate vertex. But what about the subscript? Subscript k is nothing but, it tells us, the number of rounds. Actually that k is also the vertex, intermediate vertex. So if we have 4 intermediate vertex, we have to go till k equal to 4 to compute this, the solution. So remember that a of k is around where we will find from each vertex I to each vertex j what is the minimum cost. The minimum cost will be cost of I comma j from the previous round, which is a direct path, and minimum of a of I comma I minus a of k minus 1, which is from previous round, the cost from I to k plus the cost from k to j. So that is how we do it. Then what is A actually? A is a matrix. A is a matrix which will be storing the cost of what, or we can say that which will be storing the minimum cost from vertex I to vertex j. So A is actually a matrix. Now let us look at how to solve this problem. We have the equation over here. We will have this graph, and first thing is we have to find A of 0. That is when k equal to 0. That is 0 a vertex here? No, there is no vertex. It is actually an initial stage. So A, I said it will be a matrix. So here let us look at A of 0, which is a matrix. Now we have 3 by 3 matrix because there are 3 nodes. If you have 8 nodes, you will have A0 as the matrix as 8 by 8 matrix. Now initially, if I equal to j, that is 1 to 1 will be 0, 2 to 2 will be 0, 3 to 3 will be 0. And rest of the things are filled with the cost of the edges. And remember, this is a directed graph. Now here I have some a space blank. The rest of the things are filled up with some values, which is part of the cost of edges. Now there is a blank here because there is no edge from vertex 3 to vertex 2. I is taken as row and j is taken as column. So I from 3 to 2. There is no edge from vertex 3 to vertex 2. So when there is no edge initially, we say that it is infinite. The cost is infinity. So this is actually, A is actually a matrix. Matrix, I mean a place where we will be having minimum cost to reach from one vertex I to another vertex j. Now, when k becomes 1, that is, we are choosing vertex 1 as the intermediate vertex and trying to find the path, all the minimum paths for I to j. 1 is taken as intermediate vertex. So we don't take I and j and find the path. We take k. We take intermediate vertex and try to find the path. So we say this as a of 1 I comma j, which will be minimum of a of 1 minus 1 will be a of 0, because k minus 1 is there, k is 1, 0, I comma j, and a of k minus 1 will be 0, I comma k is 1, plus a of 0 of 1 comma k because 1 comma j because k is 1. So we are, with using this equation, we will be able to find now all the path from I to j, taking vertex 1 as the intermediate vertex. So obviously we'll have to fill this matrix, which is called as a of 1. Now a of 1 I comma j is nothing but a of 1 comma 1, because we have to find this value 1 comma 1. I is 1, j is 1. So it will be minimum of a of 0 of 1 comma 1 comma a of 0 of 1 comma 1, because I is also 1, plus a of 0 of 1 comma j, j is also 1. So it is, this is the equation we get. मैं चला रहा हूँ. So this is the equation we get to fill this value, which is nothing but finding the cost from 1 to 1. So obviously if you look at this, a 1 comma 1, a of 0 of 1 comma 1 is 0, 0 plus 0 plus 0 will give us 0 itself, so 0 is stored here. Then I will be 1, j will be 2. So 1 comma 2 we need to find, so minimum of a of, you have the equation I comma j, so a of 0 of 1 comma 2 and minimum of a of 0 of 1 comma 1, because I is 1, plus a of 0 of 1 comma 2 because j is 2. This gives us minimum of a of 1 comma 2. 1 comma 2 is 4. 1 comma 2 is 4 over here, plus and minimum of 1 comma 1 is 0, plus 1 comma 2 is 4. So 4 comma 4 minimum is 4 itself, so this remains 4. Then what we have is from I1 to J3. So this will be the equation, a of 0 of 1 comma 3 and a of 0 of 1 comma 1 plus a of 0 of 1 comma 3. So 1 comma 3 is nothing but 11 at this place, you can see, and then 1 comma 1 is 0 plus 1 comma 3 is 11. So minimum is 11 itself. Then we need to find 2 comma 1. I will be 2, j will be 1. So if you substitute in the equation, you will be having this as the result. This time just going through, and I mean you can yourself calculate and see that this is how the matrix A of 1 will be filled up and filled up with these values. So I have already performed these calculations here. So if you just try to use these, you will be filling up the values. So then the last thing is a of 3 comma 1, that is I will be 3, and we have to perform these 9 times, so I mean 3 times, so that we fill up all the values of a of 3 to 1, and then a of 3 to 2 and a of 3 to 3. So you can find here at this stage that the value 3 comma 2, or from vertex 3 to 2, there was no direct edge. So it was infinity. Now you can find that 3 to 2 is minimum of a of 0, 3 to 2, which is infinity, and a of 0 of 3 of 1. 3 of 1 is 3 plus 1 comma 2. 1 comma 2 is nothing but here I is 3, I is 3, j is 2. So we are trying to actually find here, if you look at this, 3 to 2 taking 1 as the intermediate vertex. So direct part is infinity from 3 to 2. But if we take 1 as the intermediate vertex, we are going from 3 to 1, 1 to 2, which can be reached in 3 plus 4, which is 7. So instead of infinity, we fill up this value as 7. So this is how, taking 1 as the intermediate vertex, we are able to compute the shortest, all pairs shortest path. Now comes taking 2, vertex 2 as the intermediate vertex. So we have to now compute a of 2 for all vertices I2, j, minimum of a of 1 of ij, and then a of 1 of I comma 2 plus a of 1 of 2 comma j. So k becomes 2 over here. So taking 2 as the intermediate node, we have to compute all the paths from vertex I to vertex j. So formula, I have to substitute. So remember, k is 2, but we have to start from I as 1 and j as 1. Then move on to I as 2, I as 1, j as 2, I as 3, I as 1, j as 3 to fill this row. Now I have already computed. I'll just show you what are the calculations here. And then we will just look at if there is any change in the value, we will just discuss about that. Okay, now just wait. There is a change in the value over here. So we will just try to look. Now, 1 comma 1 was 0 itself. 1 comma 2 is 4 itself. But 1 comma 3 we had 11. Now, take 11 when we took 1 as the intermediate vertex. Though going from 1 comma 3 and taking 1 as the intermediate vertex doesn't make sense. It's a direct edge itself. But anyway, 1 comma 3 was 11. But taking 2 as the intermediate vertex, from 1 comma 3 we get 6 as the result. I mean, as the minimum cost. Further reduction in cost. So how did it happen? So here, from 1 to 3, but I is 1, vertex j is 3. So from vertex 1 to vertex 3, previously we have direct path, that is 1 to 3, or whatever path calculated, computed previously is 1 to 3. Then when vertex 2 is taken as the intermediate, we are going from vertex 1 to vertex 2, then from plus vertex 2 to vertex 3. So this 1 to 2 is 4 and 2 to 3 is 2, which is minimum of 11 and 6. Obviously we have 6 as the minimum, so we got this change in the value. Now we have to compute for the second row. So I will be 2, j will be 1, then j will be 2, then j will be 3. So this is how we perform the computation. There is no change in this value. Obviously there will not be any change in going from 2 to 2 because it will always be 0. Whenever we have when we have I equal to j, the value will always be 0 because we do not consider self loops. That is the reason. Always when I is j, in whatever matrix you take, I is equal to j, always it will be 0. Now this is how we compute for I equal to 3 and all the values of j. So this is how we fill up the entire matrix for A of 2, where 2 is nothing but it's the intermediate vertex. Now, once we are done with A of 2, I mean A2 matrix, we have to consider k equal to 3. So k equal to 3 means taking 3 as the intermediate vertex. So A of 3 has to be computed for every vertex I and every vertex j. Now you can see here, this is the same from I to j. If there is a already path, a minimum path from previous computation, taking 2 as the intermediate vertex, or taking 3 as the intermediate vertex, now the value of 3. So we compute A of 3 for all values. So first we have to compute for A of 1 comma 1, A3 of 1 comma 1, then 1 comma 2, then 1 comma 3. This is what already have computed these values over here. There is no change in the values. So you can just do it yourself, practice it, and then you will be get the values. So I'm just showing you the different values, how they are have computed, so that it will be easy for you to keep track of yourself. So finally, what we have is, we have A3 as the matrix. Now next thing is, should we compute A4? That is K when K equal to 4? No. K is number of intermediate vertices. So K is around, K is number of intermediate vertices. So how many, the number of intermediate vertices we have, those many number of rounds we have to perform. So we when we compute all the values of K, A3, what that means is we got the shortest path among all pairs. So this is how we can take, there are a lot of iterations involved in this, and we have to compute multiple matrices, and then we will be able to get the result for the all pair shortest path. So this matrix, which has written A3, is the ultimate matrix, where the values from I to j, I representing the row, j representing the column, where every I to j gives us the shortest path, and this is called as all pairs shortest path problem. And it's a Flyod-Warshall's algorithm, or Flyod-Warshall's method of computing using dynamic programming. Now remember that I have already in previous sessions, we talked about dynamic programming, that at every step we take decisions. That decision, we assume that it will be an optimal decision, or will lead us to an optimal solution. In this case, the optimal solution is the least cost, or what we call here, that the optimal solution in this case is nothing but the least path. And since we are talking about least or minimum path, this is an optimization problem, or the optimization problem is a minimization problem. So we are trying to find minimum cost. So this is a minimization problem. Now let us look at the algorithm. Algorithm seems to be very simple, because what we have to do is, we have to just iterate and find the result there. So this all paths is a Flyod-Warshall algorithm. This is a cost adjacency matrix, and A is a null matrix initially, and N is the number of nodes, a number of vertices actually. So what we initialize, I mean, this 2 for loops is to initialize the cost A, the matrix A at A0. This will be the A0 matrix, whose cost will be, which will be initialized with the cost adjacency matrix. Then, you know that we have to, for every I and j, we have to perform k number of times, taking k as an intermediate vertex. And how many intermediate vertex we will take is equal to number of. So we start with first intermediate vertex, then second, third, fourth. We go until n number of intermediate vertices. So this two nested for loop is again inside a nested for loop k, and this is the same equation. A of I comma j is equal to minimum of A of I comma j comma A of I comma k plus A of k comma j. Now here we don't say A of 0, A of 1, A0, A1 matrix, A3 matrix. The same A matrix, everything happens. The A matrix is because it's a algorithm is a programmatic way. So this A matrix will get updated every time the for loop runs or the iterations happen. So if you just look at this, this will be taking O of n square, O of n square, because there are two for loops. And this I and j part with two for nested for loops will be taking O of n square. But since we have k, which will be going from 1 to n, so since it will be running n times, so overall time complexity will be O of n square into n, which is nothing but O of n cube. So this is the time complexity, or the amount of time consumed by this algorithm, which is nothing but O of n cube. And remember, always in dynamic programming, we have to store the previous value. We have to have previous values so that from there which can lead us to a optimal solution. So this was there, and most of the time the problems which are solved through dynamic programming will be having some kind of tables or some kind of sets where we will be storing that data. And depending upon that, because why we will be storing, because we don't want to recompute that data again and again. So that is why in dynamic programming, there will be tabulations or storage of previous results. So this is what is all about all pairs shortest path.